So what we're going to do for the rest of the unit is kind of take everything that we have done so far and put it all together. So I have this really nice little box at the top of your notes for 4.4 on the 3 different methods for solving systems that we have learned and when it's best to use each one. So what I want you guys to do right now is read through that box, and on your paper I want you to circle keywords for each one. So for graphing, read when to use it and then circle keywords that would help you quickly be able to identify when to use graphing. So when we're talking about graphing as a method, you want to use graphing when you want a visual display of the equation. So I would circle visual display, or when you want to estimate a solution. So for me, and what you circled might have been different, but I circled visual display and estimate. Okay. Remember, we talked about how graphing is not always the best method, right? Because it's not always 100% accurate, which is why it shows that we use it really only when we want to estimate. Another time that graphing is a good method is if we are talking about maybe like a word problem only in the first quadrant and we want to see what's actually going on. The other method that we talked about was substitution. So that's when we would take one value and substitute it in for the other. Substitution is a great method if we have already solved for one of the variables. So that means we have x equals something or y equals something, or if it's really easy to solve for one of the variables. So I also circled easy to solve. So that's like if I have maybe 3x plus y equals 10, it's really easy to get that y by itself, right? So sometimes substitution might be a better method if you can easily isolate either the x or the y in one of the equations. And then on Thursday, you guys talked about elimination method. Elimination is actually my favorite method because it takes away one of the variables pretty quickly. So we would use elimination when the coefficients of one of the variables are the same or opposite, or when it's not convenient to use graphing or substitution. So I also circled not convenient. Basically, when the other 2 methods take too much work, elimination usually is the better way to go. Okay? So that's kind of just a summary of everything we've done so far. And now we're going to go through a series of word problems, all different types, and determine which method is the best, and try and put everything that we've learned together in terms of one word problem. So we're going to first talk about finding a break-even point. So let's look at number 1. And I'm going to blank out this one so I have more space. Okay, so a fashion designer makes and sells hats. The material for each hat costs $5.50. I'm going to underline that, because that's some important math information. And the hats sell for $12.50 each. So I'm going to underline that as well. Then it says that the designer spends $1,400 on advertising. So I'm going to underline that. And the question is, how many hats must the designer sell to break even? So I'm going to circle it and put a question mark. Okay, so the question is, after how many hats does how much I make and how much I spend become equal? So we're going to actually write 2 equations for this. The first equation is for the cost of actually making them, so our expenses. But before we do that, we have to actually define our variables. Do you guys want to use x and y? Okay, so x is going to be the number of hats that have sold, or number of hats. And y is going to be, what would y represent if x is the number of hats? Total cost. So y is going to be total cost. Okay. So let's write an equation first for how much our fashion designer spends. So I'm going to just label it as expense. So we are only interested in the information that talks about how much our designer has spent up front. So, you know, with business, you have to put money into your business before you can actually start making money. So the total expense is going to be Y equals. And what is one of her expenses? Who can tell me one of her expenses? Jen, what's one of her expenses? The materials for each hat. How much does she spend on each hat for materials, guys? $5.50. So it's going to be 5.50 per hat. So that means times X, the number of hats, right? Does she spend her money on anything else? Yes. What else does she spend money on? Advertising. $1,400. So plus $1,400. Because she is spending $5.50 for each hat plus an additional $1,400 up front for advertising. So that's her expenses. What about her income? So we also have an equation and enough information to talk about how much money she makes. What's her income? How much did she make on these hats? Total. $12.50 each. So that's going to be Y equals $12.50 times X. They don't give us any more information than that, right, guys? Okay, so let's think about this. I have two equations, and I am looking for the break-even point. So what does that mean? Where they meet. So if I were to graph these, it would be the point where the two lines meet. Basically, we have a system of equations here, and I am looking for when the cost is equal. Which method to solving this system do you think we could use? How many of you vote graphing? Good. How many of you vote substitution? Excellent. How about elimination? Okay. You could use elimination on this. I would probably use substitution because, look, we already have y solved for in the expense equation and y solved for in the income equation. So we just have to choose one to substitute in. I would probably substitute 1250x in for y up here at the top. Okay? So I'm going to take that 1250x and substitute it for y in the other equation. So that's going to give me 1250x equals 550x plus 1400. Now solving this should be a piece of cake. So we subtract 550 from both sides. I get 7x equals 1400. And then divide both sides by 7. I ran out of room. So I get x equals 200 what? What does x represent? Good, hats. Did I answer the question? How many hats must the designer sell to break even? Yeah, so that is my answer. The question didn't ask how much money 200 hats costs to make or how much 200 hats earns her. It's going to be the same no matter what because we set the break-even point. It only wants to know how many hats she had to sell. So we're done. So the answer solution would be 200 hats. Make sure you label it hats. Okay. So we have a local zoo, and they are filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. So I'm going to underline the 50 gallons of water and the rate, 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. And the question is, when will the two tanks have the same amount of water? So we have to first define our variables. So x is going to be the number of hours or time in hours. And then y is going to be the total number of gallons in the tank. So total water in gallons. Okay. So x is the time that it's filling. Y is the total gallons inside the tank at any given time. So let's write an equation for tank 1. And then I'm going to have you guys write an equation for tank 2. So first we're trying to find the total gallons. So that's going to be y equals, our rate is 10 gallons per hour. So I'm going to multiply that by the number of hours. So 10x, that's my rate. Plus, how much water is already in there? How much water is already in tank 1 to start? 50. So what I want you guys to do right now for me is write an equation for tank 2. Kiki, do you have it already? What's your equation?
Y equals
3x plus 29. Thumbs up, you agree. Thumbs down, you disagree. Good. Okay, ladies and gentlemen, which method would you use to solve this system? Graphing, substitution, or elimination? Any ideas? Do we already have a variable solved for? Yeah, we have y equals and y equals. So according to our notes at the top, let me go back to those. If we already have one variable solved for, substitution is a good method. So we're going to do the exact same thing we just did in the two previous problems. We're going to take the whole expression, 3x plus 29, and substitute it in for y in the tank 1 equation. So it's going to give me, I'm going to go over here, 3x plus 29 equals 10x plus 50. Okay? Basically, we're finding the break-even point again. To solve this, I always like to keep my variables positive, so I'm actually going to subtract 3x from both sides. If you want to subtract 10x, you can. You're going to get the same answer in the end regardless, as long as you are doing your arithmetic correctly. So that gives me 29 equals 7x plus 50. And then I subtract 50 from both sides. So that gives me negative 21? Yeah. Equals 7x. Divide both sides by 7. And I get x equals negative 3. So after how many hours will the two tanks have the same amount of water? Negative 3 hours. Does that make sense? Why? Well, but we're filling the tank. Why does this answer not make sense? Can you have negative time? So will these two tanks ever have the same amount of water? No. So in a word problem, you have to always kind of assess your answer to see if it makes sense. This should also make sense if we have two tanks that are the same size and one already has 50 gallons and it's filling way faster than the second tank that only has 29 gallons and is filling at a rate of 3 gallons per hour. Does it make sense that they would ever have the same amount of water in them? Tank 1 is filling up way faster, right? So we would say that these two tanks never have the same amount of water. And then we have to write a sentence that explains that. So I'm going to write it off to the left on mine. So the 2 tanks will never have the same amount of water because -3 hours, we call that not a viable solution. So a viable solution means that it's reasonable, it makes sense. So -3 is not a viable solution because it does not make sense. So we would say because -3 hours is not a viable solution. Basically, that's a very academic way of saying -3 hours does not make sense. Okay? So for number 4, we are talking about splitting $1,500 between 2 savings accounts. Okay, so $1,500 is kind of how much I start with. So I'm going to underline that. So $1,500 is how much money I have. Okay. Account A pays 5% annual interest. So I'm going to underline that. That's important. Before we even go on, when we're talking mathematically with percents, can I use 5 or do I have to change it to a decimal? What is 5% as a decimal? Good, 0.05. So right above it, I'm going to write 0.05 just so I don't forget. Probably the most common mistake I see with students is they remember you have to change it to a decimal, but they don't move the decimal 2 spaces over. So a lot of times students will change 5% to 0.5, which is actually how much? 50. Account B pays 4% annual interest, so I'm going to write 0.04 right above it. After 1 year, you earn a total of $69.50 in interest only. So that's how much, if we calculate your interest, you earn. And this is kind of how banks do it. So I should have brought my bank statement for you guys to look at. Every year or every month, at the end of each month, the bank calculates how much interest I make by just keeping my money with their bank. And they deposit that amount into my account. Now, monthly, that doesn't show up to very much. Usually, it's like 20 cents a month. But they calculate it based on how much money I had in the account, whatever my interest rate is, and then they deposit that much money back into my account. Does that make sense? So it depends on how much I have currently in the bank at the end of the month, and that's how much interest I make from the bank, and they just calculate it and then add that amount in. So even though $69.50 does not seem like a lot, 5%, 4% annual interest rate is pretty high. So because usually I make like 15 cents a month on interest, which is not that much. How much money did you invest in each account? And that's the question that we're trying to answer. So we're trying to answer how much money I put in account A and how much money I put in account B. So those are going to be my variables, okay? So X is going to be the amount of money in account A, and Y is going to be the amount of money in account B. So we're going to write an equation, not for each one of these, but we're going to write an equation, one for the amount of money that we invested in each account, and one for how much money we earned in interest, because that's the information that's given to us. We know that we split the 2 accounts or the amount of money into two accounts. So our initial amount is going to be the first equation. So the first equation is going to represent the initial amount. So let's think about this. If I had $1,500 total, and I put part into account A and part into account B, how could I represent that? Yeah, we're going to add the two accounts together, and it should equal how much money? 1,500. So X plus Y equals 1,500. Does that make sense? So the amount of money that I deposited in account A plus the amount I deposited in account B should be a total of 1,500, right? Yes? Okay. So then the second equation is just going to have to do with the interest earned. So let's talk about interest earned. What's my interest rate for account A? Kevin, what's my interest rate? 5%. So I'm going to take 5% and multiply it by how much money is in account A. That's how the bank calculates your interest. They take your rate and they multiply it by how much money you have. Plus, what's my interest rate for account B? Rose, what's my interest rate for account B? 0.04. So 0.04 Y, right? Times how much is in account B equals what, guys? How much money did we make in interest? $69.50. So equals $69.50. So there are your two equations. I'm even going to help you guys with which method I would use. Looking at this second equation, there is not a variable that seems really easy to solve for, right? But look at your first equation, the initial amount. X plus Y equals 1,500. Can you easily solve for one of those variables? What do you guys want to solve for, X or Y? X. So that means we're going to subtract Y from both sides. So just off to the side, I'm going to rewrite the equation as X equals 1,500 minus Y. It looks like I'm going to use the substitution method. I'm going to let you guys work on this. Just as a side note, I probably wouldn't worry too much about the decimals. You can just use a calculator if you want. Big thing I want you to be aware of, though. When you are substituting that value in for X, the whole thing stays in parentheses because it's one value, right? So make sure that you put parentheses around the 1,500 minus Y when you plug it in for X. So it looks like you might have to use the distributive property. Okay? So I want you guys to work on this just for a few minutes. I already got you started. For number 5, I gave you just a little information about wind speed and how that's calculated. Basically, I'm not going to have you read the whole thing, but what this says is that when you are going from the west coast to the east coast, the wind acts as a tailwind for you, and tailwind means that the wind is pushing you from behind. So would you expect that you would go faster in the air or slower if it's pushing you from behind? Faster. If you are going from east to west, the wind acts as a headwind. So if you're flying from New York to Fresno, you have a headwind, and that means the wind is coming from you straight on. So would you expect that to make you faster or slower? Slower. So the way that plane speed is calculated is the plane speed on the ground. On the ground, what does the speedometer tell me that it's going? and then we either add or subtract depending on if it's a tailwind or a headwind. This is a very simplified version of how it actually works, but it gives you the idea. So let's read the problem, and we're going to write two equations to go with this situation. So a traveler flies from Charlotte, North Carolina to Los Angeles, California, so going from east to west. At the same time, another traveler flies from LA to Charlotte, so going from west to east. The airspeed of each plane is the same. So I want you to underline that. The planes are going the same speed in the air. Okay? The ground speeds are shown below, and I know that it's kind of small. What is the airspeed? What is the wind speed? Okay? So we want to write an equation for the tailwind and an equation for the headwind. The variables are already defined for us, so I'm just going to circle them on here to kind of save time. Wind speed is W and airspeed is A. Okay, so I'm just going to circle the variables so that we know what we're dealing with. But basically we're going to write one equation for wind speed or tailwind, one equation for headwind, and then we're going to solve that system. So the tailwind first. So I'm just going to label it tailwind. Okay, so tailwind. My airspeed is the same for each one, so it's going to be A. And then if I have a tailwind, am I adding the wind speed or subtracting the wind speed? Is the tailwind helping me or hurting me? Helping, so we're going to add. So plus W. And we're going to call the ground speed G. Okay, so A plus W equals G with the tailwind. So what do you think the equation for the headwind is going to be, guys? Yeah, so for the headwind, we're going to subtract. So it's going to be your airspeed minus your wind speed equals G. Do we know what we want to plug in for the ground speed for each one? Yeah, it's actually given. So I'm going to subtract that G. Sorry. I forgot that it was given in the picture. What's my speed with the tailwind? So going from Los Angeles to Charlotte, what's the ground speed there? 550. So equals 550. And going from Charlotte to LA, what was the ground speed? 495. Oh my gosh, you guys. Does this look like one method? Is one method like really screaming out to you, Rose? Yeah, elimination. Because look, I have positive 1W and negative 1W. So if I add those two equations straight down, what's A plus A? 2A. What's W minus W? 0. So it eliminates. Equals 550 plus 495 gives me 1,045. I already did that for you. And then what do I do to solve for A? Divide by 2. So A equals 522.5. Miles per what? Hour. Good. So my airspeed (522.5 miles per hour). How can I solve for the wind speed? Plug it in. So your choice. Plug in 522.5 to the tailwind or the headwind problem. I don't care which. I'm probably going to do the tailwind because that keeps W positive. So it's going to be 522.5 plus W equals 550. Subtract 522.5 And I get W equals 27.5 miles per hour. Do these speeds make sense? Are they all positive? Yes. So my wind speed was 27.5 miles per hour. Okay? Number 6, I'll have you guys do that on your own in just a second. I want to do the money problem with you really quick. Number 6 is talking about current in a river. The concept is exactly the same as air and wind speed. If you are going upstream, that means you are swimming the same direction that the stream is going. So that acts as the tailwind, right? It's going to help you. If you are swimming downstream, you are going against the current. So that's going to slow you down, right? So that's the difference between upstream and downstream, but then the process is exactly the same as what we just did. But I'm going to skip over that one right now so we can do the money, and then I'll have you guys do number 6. You have 42 coins in your wallet. Underline that. That's important. Consisting of quarters and dimes. Okay, before we even move on, we're going to be talking about total dollar amounts or amounts of the coins. What's the value of a quarter? 0.25. So I'm going to write that 0.25. Remember, we're talking about the value, so you have to do it in terms of a decimal. Okay? What's the value of a dime? 0.10. Actually, and I'm even going to circle quarters and dimes. You don't have to. That's just where I'm going to get my variables from. The total value of the coins is $7.80. So total value is $7.80. And I want to know how many of each type do I have in my wallet? They give us 2 sets of information here. That first sentence tells me how many total coins I had, right? So the number of quarters plus the number of dimes should add up to how many coins? 42. So that's your first equation right there, guys. Q is the number of quarters plus D, the number of dimes, should equal 42 coins. Okay, there's your first equation. The second sentence tells me about the total value of the coins. How can I calculate the value of the quarters? I multiply the worth of the quarter times how many I have. So that's going to be 0.25 Q plus, how do I calculate the value of the dimes? 0.10 D, and that should add up to how much? 780. Oh my gosh, this is very similar to that interest problem that we just did, right? Almost exactly the same, okay? So here's what I want you guys to do. What method looks like it might be quickest for you to use? Substitution. So what I want you to do right now, you can work by yourself for just a couple minutes, and then I'll let you work with your partner. Start solving this using substitution.